My name is Pedro. I am a software engineer here at Aubay, and today I'll be presenting to you uh, a webinar about building microservices with Spring Boot and Java. All right. Okay. First of all, let me introduce a little agenda for our presentation. We are going to get to know a little bit about what is microservices architecture, uh, some key topics about resilience, uh, service discovery and communication between services, API gateway, and load balancing. And I will briefly touch the concepts of containerization and observability. Just to remind, we have only 30 minutes, and I really want to open to some questions at the end. And also, if we have time, show a little bit about a demo. But okay, let's start. So, what can you expect to take away from this webinar? So, some key concepts about microservices, of course, some advantages they offer over monolithic applications, why we need to care about resilience in our microservices, how to use patterns like circuit break and retries, uh, how microservices communicate with each other, and why we need a service discovery and how it works. The key role in API gateway and how we can manage load balancing to our microservices. Uh, sorry. Okay, already muted. Okay, the importance of containers with all this context of microservices architecture and some understanding about what is observability, what we need, some practices, and if we can have time at the end, the a few small demo. Okay, so microservices. What is microservice architecture? So it's a strategy to software development where we get large applications or complex businesses and divide into some into smaller parts to divide and we can say divide and conquer this smaller topics. It can be evolved indefinitely, developed, deployed, and scaled all by themselves. We have some pros and some cons because nothing is a silver bullet. The pros are scalability. They can scale independently. They can be developed by multi teams and multi squads. They can use different languages. You don't need to be stuck with only Java or only Python or only Node. You can use a bunch in a product way. We can use a lot of languages. Of course, in the same microservices, it's really complex to use the different languages, but in a product wise, we can use a polyglot program. Okay, but we also have some cons because if we have more services, it increases our complexity. We need to get a more sophisticated logging way to identify issues or to follow requests. We need to, when we are talking about communication over the web, we need to be aware about network concerns such as latency and all of that stuff that comes with network communication. Different from monoliths where we have a single code base with all the code, all the product. We can have different repositories with different teams, with different due dates and different schedules. So we have a lot of things that we need to consider when using microservices architecture. We have, of course, some success cases and very known ones, like Netflix, like Amazon, like Uber. We have a lot of dependencies and libraries made made by them, that is really commonly used, and we will see here in this project, in this presentation. Okay, so when not to use microservices. Okay, considering that we need to have a lot of services to be microservices architecture, it includes more than one service. For small projects, it's not wise to select the microservices architecture, since we are going to have more trouble maintaining a lot of code repositories and authentication and roles and all this kind of stuff that goes around the project, not only the code source where we are going to work. Okay, so since let's pretend that we chose the microservices architecture and now we need a microservice. What is a key concept when using microservices? We need to be resilient. So it's not a single application. It is a whole system of applications, and we need to make sure that if one fail, it won't fail the others. Like if we have in e-commerce that have one service for recommendations and another one for the purchase, we don't want to affect the purchase or the payments microservices if the recommendation is down. The recommendation is a secondary service for our whole product. So we need to guarantee some concepts when we are dealing with microservices and make them more resilient. Of course, that's the name. Okay, so some key concepts that I separated here is that we need to fail fast. What this means is if we are trying to reach for our database or trying to reach to another service and it's taking too long, like 30 seconds, 40 seconds, or more than we can expect to delay, we need to terminate that request and fail as fast as possible to not compromise other steps of our system. Once we are failing, we need to graceful fail. What is to graceful fail? We need to fail, we need to respond with an error, but we don't want to break everything apart. We don't want to show errors and shut down our application. We just want to return an error and say to the consumer or the client that we are not available that time and it should try another time. With this concept that we are trying to return an error, we also have the retry logic. So once we got an error, we can implement some techniques or algorithms that can retry this method or retry this call and see if it's already up. We have another concepts like fallbacks, that when our service fail, what we are going to do. We have the fault isolation that guarantees that if one service or one part of our system breaks, only that break part is going to be affected. We have a lot of others that if I put all of those here, we won't have time, but we have also some tools that can help us guarantee this resilience, such as Resilience4j. We have Spring Boot with a whole bunch of libraries and concepts already implemented in Spring Boot. And we also can combine the microservices architecture with an event-driven architecture, which means we are going to asynchronously respond. We are not waiting for any response. We can delegate these problems like fallbacks or retries to other services or other parts of our system. If anyone here was present in our last meetup about Java, you will recall the Java Resilience4j lab that we made. I will share this presentation for you to search a little bit about the code, but in this code example, we have implemented the Resilience4j and with Spring Boot in a project. It has all the readmes that you need to complete this lab. It's really nice. So make sure to give a look after this presentation. All right, moving on. Service discovery and communication. So what is a service discovery and why do we need it? So let's think when we are using some microservices. Everyone here have already heard of horizontal scaling, when we have multiple pods or multiple instances of the same service. Okay, but since my client is communicating with the server and the server has now escalated, how do I know which IP do I need to call? What are the new IPs for the new instances? That's the job for service discovery. Each server side or client side can search or fetch for new services or new instances that are registered in the service discovery. So the service discovery is like a database of instances of clients and servers, where we can dynamically fetch and communicate with each other. So we have these two types of the service discoveries. We have the client side, which is implemented on, of course, the client, and it queries the service registry to find the available instances of the server that it needs to call. We have the one benefit, one pro for this approach, that is the full control. So you can implement a filter or whatever logic you want to do to call zone A, by example, if it has a header X, or zone B if it has a body Y. I don't know. Any filter you can do, it's really customizable. But we also have a con, or a negative side, that is the need to implement load balancing logic. So you need to in your client side, define how many times you want to call B or A, instances A or B. And when we are working with service side, one good point about it, one pro, is the abstraction of the responsibility from the client. So we don't want to determine which logic we want to call A or B, or how many times we want to call A or B. We just delegate this for the server or our API gateway that we are going to talk a little bit in a second, to load balance, to balance our requests. But this also comes with a trade-off. So if we are only calling one service and it's going to determine which instance of our server microservices is going to call, we have a single point of failure. And this is a really great concern. Once we don't want, in a microservice architecture, we don't want to have any single point of failure, because if the API gateway is down, the whole system is down, and we need to take this in consideration and work around it. Also, in our client and server communication, we have two types of communication. We have the synchronous, that is the most common and widely used communication type, that is requests and response, where you make a request to the server and wait for the response. It uses the HTTP REST model, and also use JSON or XML that is widely known and widely supported. But we also have some cons or some negative sides, that if we need to wait for a response, if this server crashes or if it is unavailable, it can lead to cascading failures, and it is a really bad thing to happen. So that's why we also have the asynchronous communication, or the event-driven, the messaging communication, where this approach is less coupled, because we don't depend on our server response. We don't need to wait for a response, so it has no wait time. It can be queued, so it can follow an order. We can pub or or send the requests, and it will guarantee the order. But we also have some trade-offs as well, because since we are talking about a message broker, we need to implement this message broker. We need to debug this message broker. So it's another service that we are including in our infrastructure that needs to be configured. And that's why in the beginning of this presentation, I said that if your project is small, you may not consider using microservices because it's really more complex than you can imagine or plan. Okay, API gateway and load balancing. Okay, so what is an API gateway? It's more like a router. Let's say like this. You can think about router with a lot more features, but the key responsibility is to filter requests, direct requests. This is the most commonly features that is used, but it has a lot more that I don't have time about to define here. But the key ones is the routing and the load balancing. So imagine that you have 2 instances of your server and your client is sending requests. You have some algorithms that will balance this request. So if we use, for example, this round robin, it will cycle over the instances, sending one request to each other. So the first one goes to A, the second goes to B, and the third goes to A again. And we have other algorithms. We have the least connections. So if we have a lot of requests going to A, we need to balance this. So we're going to call some to B. And if now B has more connections and has more requests, we're going to go back to A. And we also have the IP hashing that guarantees that if the client sends a request and the request is responded by A, it will always be responded by A because it makes a hash of the IP of the client. That's pretty straightforward. We have some examples about of API gateways. Oh, I forgot to mention that we have some examples of service discovery that we can mention here. We have Eureka from Netflix. We have, if I'm not wrong, we have Zookeeper, that is also a service discovery used with Kafka. I think this is the most common ones. Yeah. And for our API gateway, also we have some examples that we can mention here at Jinx. We have AWS API gateway. This is a very well known. We have Spring Cloud Gateway as well. We are going to mention in our demo if we have time, and we also have Congo. This is another API gateway tool that we can use. Okay, so I've talked about API gateway. I talked about load balancing. You can use different tools for each one, but it's really common to use an API gateway that already balance your requests. Okay, wonderful. All right, so how do we use everything together? How do we combine everything, the API gateway, the service discovery, the microservices, everything in one place? The way the things are being used today most commonly is with containers. Containers are lightweight abstractions of a operational system that it creates an isolated part in your system that will run code, runtime, libraries, and the system settings all in a small chunk of your system, reusing your system's hardware. And it will guarantee that every time that you run this image, that what's called the package with all the information, this image, all the time that you run this image, it will run exactly the same. It will use every time the same runtime. It will use every time the same code, the same library, the same system settings, and there is no more the excuse is it runs on my machine, because it can run in every machine consistently. The main goal for containers is to run in different environments and behave the same. We also have an example about a Docker file and a pipeline, CI/CD pipeline, in our last meetup. I will leave the links here in the presentation, but I will also show in the demonstration, in the demo. And our last topic that I will briefly talk about, just to leave some time to Q&A and the demo, is observability. All right. We have our API gateway, we have our service discovery, we have our instances that is resilient. How do we know that we achieved the goal? How do we know that the API gateway is sending messages to both instances? How do we know that our instances are responding in a resilient way? We need to observe this, and as the name already state, observability does this. It is a concept to understand the state of our whole application, of our whole system, and guarantee that we are working as we expected, collecting key insights, as it's written here. We also have the implementation of this concept in our last meetup. So yeah, that's it. This is important, so we know that we are doing things right, and we can collect data to know if we need to act or to modify any configuration in our services. Okay, I spoke really fast, and I am tired. So if you have any questions, feel free to ask. Here it is my LinkedIn, my GitHub, and the source code for this presentation. I hope everyone got to understand a little bit about the topic. If you don't have any answers, any questions, sorry?
Maybe a quick one.
Okay, perfect.
Do you have any advice regarding when you are starting a new project and you need to decide? You said that the small one don't need to be split on different microservices, but how do you know that you would need to scale enough? I mean, should it start being like a monolith, and then when you need a new service, then you start to think on microservices, or it is a monolith until it needs to be microservices?
Yeah, so I really have a personal opinion on this, because I work with a lot of monoliths architectures, and for me, the microservices architecture is more about single responsibility than everything else. So of course, you need to start from somewhere. I always recommend to start with a monolith, because if you start with a microservices architecture, you are going to try to kill a fly with a bazooka. So the first thing is to create a MVP, and this MVP is probably going to be a monolith. But when you are upgrading your software and you see for yourself that you are moving further away from the responsibility that this monolith has to do, that's the time to extract this into a microservice. You can have a monolith and start building new features in a microservices way. This will guarantee that you don't have a really huge application, and after this we are going to try and work on this application, breaking down and spending a lot of time rebuilding things that are already built. So it is not commonly or wise to start with microservices, but I think once you have a big picture of what you are building and what the project main business is, you can decide if you are going to keep adding things to this monolith, or you are going to start creating a new service. So I think the key concept here is to understand the business logic about your product, And if you are going too far away from it, you start a new process or a new service.
Yeah, totally agree.
Of course, if you have already planned a big infrastructure that you need a lot of components, you are going to use events and messages, you can always plan to go to a microservice architecture. But it's way more complex to start with a microservices than to already have a product and break it down into smaller pieces. But then you never know. Yeah. Okay, anyone has any more questions? If no, I still have some minutes to show a little bit of a demo. All right. Okay. Thank you all for being here. You are all dispatched. But if you still want to see a little bit, stay where you are. Okay, so I am reusing the last meetup code because it already has some things built, but I added in Spring Boot API Gateway and Spring Boot Eureka Server. So just to see how simple it is to prepare this. The Eureka Server is nothing more than a Java class, the Java main class, with this enable Eureka Server notation, and this is not the correct dependency. This is the correct dependency. One dependency and one class. And all you need to know, all you need to do is run. Same for the, of course, we also have some configurations, but it's really straightforward, and the documentation emphasizes that it's only this that you need. And the API gateway is just as simple as this. You have some tricks when we are talking about configuration, but it's three main dependencies and only one class. You don't even need to add any notation. You can have all configurations on your application level. You just need to pay attention on the indentation. I really suffer from this the past days. So here is where you register which components you want to balance on your gateway. And for the resilience application, Java application, I will ask you to go to the other presentation or other meetup to see it, because it's a little bit more complex. But here we have three resilient endpoints that use retry, time limiter, rate limiter, and secret break. But just for the demo, I am going to run a Docker with all our dependencies. So we have Prometheus to expose our metrics. We have an application running on West and another one on East. We are simulating here multiple zones of disponibility, of availability, sorry. We also have the Eureka server, and we also have our API gateway. And on the background, we have the Grafana dashboards that we are going to see in a minute. If we try to go to our Eureka server, we can also see that we have two instances of our backend, our named resilient backend. We have our gateway routes. Here is the endpoint for our API gateway, and we go to actuator/gateway/routes to see if the routes are correctly mapped. And in some minutes, our client is going to massively call our endpoint. Oops, sorry, this is my mail. No need to be this. This is just a bash script that's going our API gateway, and it's sending a lot of requests just to try the resilient part of our backend. And we can see here in Grafana that is already having metrics. So we have 3 instances of services. I didn't have much time to prepare this, but two of them is the resilient backend and one is the API gateway. We have metrics about circuit break states, if it's closed, if it's open, if it's half open, and we can use these metrics, these dashboards, to monitor our states of our applications. Well, that's all. If you have any doubts or anything else you would like to know about it, please let me know. You have also my contact here. And well, that's it. Thank you everyone for being here. It was a pleasure sharing this knowledge with you.
Nice.
Thank you so much.